Good day. This is J. Lord Dayday, and I will be discussing validity and reliability. Validity and reliability are closely related but have distinct meanings. A measurement can be reliable without being valid. However, if a measurement is valid, then it is usually also reliable. In other words, not all reliable measurements are necessarily valid, but all valid measurements are always reliable. Now, let us understand both terms. So, first, what is validity? Validity refers to the instrument's capability to measure what it intends to measure. In a study exploring the common causes of absences, the instrument should concentrate on relevant variables and indicators. Similarly, when a researcher formulates a problem regarding the behavior of nursing students during clinical duty, the instrument must encompass indicators or measures specific to the behavior of nursing students during those times. So, validity in research means that an instrument, like a survey or a test, accurately measures what it is supposed to measure. So, for example, if you are researching the study habits of students, your, your questionnaire should include questions that truly reflect their study behaviors, such as time spent studying or preferred study environments. So this ensures the instrument is valid for assessing the intended topic. So when we say validity, there are types of validity according to Kubis, Zinn, and Boric of 2007. So the first type of validity is the phase validity. So this is also known as logical validity. So this type of validity involves an analysis of whether the instrument is using a valid scale. Just by looking at the instrument, the researcher decides if it has phase validity. So, meaning, phase validity or logical validity is about whether an instrument looks like it's measuring what it is supposed to measure. It's a surface level evaluation based on appearance. For instance, if you create a survey about sleep habits, having questions related to bedtime and sleep duration makes the instrument look like it's measuring sleep habits. And also, factors like font size, spacing, and paper size matter too. So, ensuring that respondents can focus on answering without distractions. The next type of validity is content validity. This kind of validity is determined by studying the questions to see whether they are able to elicit the necessary information. An instrument with high content validity has to meet the objectives of the research. So, content validity is measured by subjecting the instrument to an analysis by a group of experts who have theoretical and practical knowledge of the subject. So, 3 to 5 experts often suffice. So, take note of that. The experts assess the items of the questionnaire and determine if the items measure the variables being studied. Then the experts' criticisms will be considered in the revision of the instrument. So take note of that. So, meaning, in content validity, this is about making sure if your questions gather, if it is all about making sure your questions gather the right information. So, if your research aims to understand specific aspects, your instrument, like a survey, should cover those areas effectively. For instance, if you are studying happiness, your questions should address different aspects of happiness like relationships, work, and personal life. Another good example is if you are creating a test to measure math skills. So, content validity means the questions should cover various math topics. So, ensuring the test aligns with the goal of assessing overall math proficiency. You might have math teachers review the questions to make sure they truly represent the range of skills you want to measure. So, the next type of validity is construct validity. So, this type of validity refers to whether the test corresponds with its theoretical construct. So, it is concerned with the extent to which a particular measure relates to other measures and to which it is consistent with the theoretically derived hypothesis. So, therefore, the process of construct validation is theory laden. So, factor analysis, a refined statistical procedure, is used to analyze the interrelationships of behavior data and is particularly relevant to construct validity. So, meaning here in construct validity, so this is about checking if a test really measures the idea or concept it is supposed to measure. So, for example, if you create a test to measure intelligence, the questions should relate to intelligence and not something else like memory. It's like making sure your test fits the theory behind what you're trying to measure. So, when dealing with construct validity, it is essential to have a theoretical framework related to your study. So, here in construct validity, this is about ensuring that your measurement aligns with the underlying theory or concept you are trying to assess. So, if you are measuring intelligence, for example, your questions should be theoretically linked to the concept of intelligence. So, the fourth type of validity is the criterion related validity or the equivalent test. So, this type of validity is an expression of how scores from the test are correlated with an external criterion. So, there are types of criterion related validity or equivalent test. So, the first is the concurrent. So, concurrent deals with measures that can be administered and validated at the same time. It is determined by administering both the new test and the established test to a group of respondents. Then, finding the correlation between the two sets of the scores. So, in a nutshell, concurrent validity is like making sure your new test gives results that line up with a test everyone already believes is accurate. So, for example, imagine you make a new test to measure how good people are at playing video games. You want to check if your test is good by comparing it to a test that experts already know is great at measuring gaming skills. So, concurrent validity, you give your new test to a group of gamers. At the same time, you give them the well-known gaming test that experts trust. If the scores on your test match up well with the scores on the trusted test, it means your test is good at non-measuring gaming skills right now. So the second type of criterion is the predictive. Now, so in predictive, this refers to how well the test predicts someone's future behavior of the examinees. So it is particularly useful and important for aptitude tests, which attempt to predict how well test takers will do in some future settings. So meaning, predictive validity assesses how well your test predicts future behavior. So for example, if you design an aptitude test for job performance and later find that people who scored high on your test excel in the actual job, so your test demonstrates predictive validity. It means that it predicts future success. And now let us have reliability. Reliability refers to the consistency of results. A reliable instrument yields to the same rank for individuals who take the test more than once. For example, a lady who is monitoring her weight uses a weighing scale. Early in the morning, her weight is 65 pounds. In the afternoon, it is 66 pounds. And in the evening, it is 65 pounds. Another example is, let's say a student consistently scores around 85% on a mathematics exam over several attempts. The reliability of the test is demonstrated by the consistency in the student's performance, reinforcing the trustworthiness of the test results. So there are methods in establishing reliability. The first one is the test, retest, or stability. The same test is given to a group of respondents twice. The scores in the first test are correlated with the scores in the second test. When there is a high correlation index, it means that there is also a high reliability of the test. For example, if student A scores 85 on the first test and 87 on the second test, and student B scores 92 on the first test and 90 on the second test, the high correlation between the two sets of scores indicates a strong test-retest reliability. This implies that the test consistently measures the student's mathematical abilities over time. So there are weaknesses identified in using the test-retest method according to Carmins and Zeller of 1979. The first one is, even if the test-retest correlation can be computed and established, its interpretation is not necessarily straightforward. A low test-retest correlation may not indicate that the reliability of the test is low, but may signify instead that the underlying theoretical framework has changed. The longer the time interval between measurements, the more likely that the concept has changed. So, this problem is about interpretation challenges. So, example, consider a personality test given to individuals with a 1-year gap between tests. If the test-retest correlation is low, it might not necessarily mean that test is unreliable. Instead, it could indicate changes in the individual's personality over time, affecting the theoretical framework of the test. The second weakness is the reactivity. This refers to the fact that sometimes the very process is not done logically, and sometimes a phenomenon can induce change in itself. For example, if students know that they will be retested on the same material, they might study harder and the second time, not because their knowledge has significantly increased, but because they are reacting to the awareness of being tested again. The last weakness is the overestimation due to memory, is another weakness in using the test-retest method. The person's mental recollection of his or her response, which he or she gives during the first measurement, is quite likely to influence the responses which he or she gives during the second measurement. Memory effects may influence reliability estimates. So, for example, if you ask someone to rate their happiness on a scale from 1 to 10, and then ask them the same question a week later, then their memory of their initial response might influence them to provide a similar answer, even if their actual happiness level has changed. This could lead to overestimation of the test's reliability. So going back to the type of reliability, the second type of reliability is the internal consistency. So if the test in question is designed to measure a single basic concept, it is reasonable to assume that a respondent who gets one item right is likely to get right in another item that is similar. So for example, in a math test, assessing basic education skills, internal consistency would mean that a student correctly solves one addition problem, they are likely to correctly solve another addition problem of similar difficulty. So, there are also types of internal consistency. The first one is the split half. It is a method of establishing internal consistency in which a test is given only once to the respondents. If, for example, the test has 100 items, it is divided into either a first and a second half, or a half containing all odd numbered items and another containing all even numbered items. For example, imagine a 20 question math test. In the split half method, the questions are divided into two sets of 10 odd numbered questions and even numbered questions. If a student performs consistently well on both halves, it suggests internal consistency in their math skills. For example, if the student gets 8 out of 10 correct on the odd numbered questions and 9 out of 10 correct on the even numbered questions, it implies a reliable measure of their overall math proficiency. The scores of the two halves are then correlated using the Sperman-Brown prophecy formula. So we have R sub 1 equals 2R divided by 1 plus R, where R is the correlation coefficient computed or split halves, and R sub 1 is the estimated reliability of the entire test. The second type of internal consistency is the Coder-Richardson method. This is also known as item total correlation. Helps us figure out how well the questions in a test are related to each other. Imagine, you take a test once and either pass or fail each question. So by looking at this data and calculating the standard deviation, we can find out if the questions collectively measure something consistently. If the reliability coefficient is high, it means the test questions work well together and measure the same things. For example, imagine you have a test with multiple questions, and each question is a yes or no type. You take the test once and either pass or fail each question. The Coder-Richardson method helps figure out if the questions in the test are consistently related to each other. And this is the formula we need to use in order to solve for the Coder-Richardson. And the other criteria for assessing quantitative measure, this according to Pollitt of 2004. First one is sensitivity. So this is the ability of the instrument to correctly identify individuals who have the condition or characteristics being measured. For example, a pregnancy test correctly identifies women who are pregnant. Number 2, the specificity. This is the ability of instrument to correctly identify individuals who do not have the condition or characteristic being measured. For example, a cholesterol test accurately identifies individuals without without high cholesterol. So comprehensibility, explanation. Both subjects and researchers should easily understand the required behaviors for accurate and valid measurements. For example, a pain scale where patients rate their pain on a scale from 1 to 10 with clear descriptors for each level. The fourth one is the precision. The instrument should distinguish varying degrees of the attribute as accurately as possible. For example, a thermometer that can measure temperature with decimal precision. So, the fifth one is the speed. Researchers should not rush the measurement process to ensure reliable measurements. For example, a researcher taking blood pressure measurements allows sufficient time for accurate readings without rushing. The sixth one is the range. The instrument should be able to detect the smallest to largest expected values of the variable. For example, a weight scale that accurately measures both very light and very heavy objects. The seventh one is a linearity. Measures are equally accurate and sensitive over the time range of values. So, for example, a roller that consistently provides accurate measurements regardless of where it is used along its width. And the last one is the reactivity. The measurement should minimize any impact on the attribute being measured. Example, observing children's natural behavior in a classroom without the presence of the observer significantly altering their actions. So I have here an example of establishing the validity and reliability of an instrument. This is according to Cristobal of 2003. So, since this is so lengthy, I will just summarize the main points here. So, first is the variable selection. The researcher collected information from various sources to identify variables for measuring intrapersonal and interpersonal competencies. The second one is the questionnaire drafts. So, the initial questionnaire draft had 120 items, which were refined based on feedback from advisors, master teachers, and the head teachers. And then additional variables. So advisors suggested including variables like work values, home atmospheres, etc. These were subjected to face and content validations. Next is the expert evaluation. A group of experts provided comments and ratings in response. The questionnaires was revised, no, reducing the items from 140 to 110. Next is content validation. The content validation process involves experts' comments, appropriateness ratings, and uniformity considerations. All variables received a very appropriate rating. Next is reliability. The instrument's reliability was assessed by administering questionnaires to school managers, master teachers, and TEPP teachers. The reliability coefficient computed using the person correlation was 0.75, indicating a high relationship and reliability. Next is considerations for reliability. The researcher discussed factors affecting reliability, emphasizing the importance of the time interval between test administrations. Next is a construct validity and internal consistency. Total item correlation was computed for construct validity and internal consistency using a confidence cutoff point. So, in this example, the researcher developed a questionnaire to measure intrapersonal and interpersonal competencies. The instrument underwent multiple revisions based on feedback and expert evaluation. Overall, the process involved rigorous refinement and validation to ensure the instrument's quality and reliability. So that's all for today, and I hope you learned something. Thank you for listening.